arithmetic, 23 is 23, right? If I want to write 2 times 3, I can write it as 2 times 3, or conventionally 2 times 3. Okay, but because in algebra we are using literals, A times B times C, in many cases when we are doing product, we don't bring the multiplication sign, we leave the sign out. So that is going to be A, B, C. So if I want to say 23 times X times Y times Z, this is the same as 23 X, Y, Z. You understand? So it is very important. Let's look at some examples here. 7 times Y, what would that be? 3 times 5 times A, what would that be? Let's see, 10 times R times S. Let me do this. 7 times 11 times H times K. Now let's look at how these ones. So 7 times Y, in algebra you would usually see something as 7Y. Okay, 3 times 5 times A. 3 times 5 is 15 times A is 15A. 10 times R times X will give you 10RS. 7 times 11 is 77 HK, so that will be 77 HK. So you see how this works. If you write 23 in arithmetic, it's 23. You cannot say it's 2.3. It doesn't make sense. But I can write 2A in arithmetic, and it will make a lot of sense. In arithmetic, 4 divided by 0 is undefined. In simple terms, you say that is impossible. Okay, it's more like an infinite. In algebra, it's the same thing. So for instance, if I say 4 over n, okay, I already mentioned that n here is a literal and it can take on any number, right? Yes. And so 4 over n here is always true except when n is equal to 0. So it means that n here can take on any number. It can take on 2, and that will be 4 over 2. It can take on 1000, and that will be 4 over 1000. But what that means is that for this means that for this to work, n can never be equal to 0, because then you are going to have 4 over 0, which is undefined. This is also one thing that you would see a lot in algebra. Let's look at some examples. Let me write 10 over B, A over 3 C, and let's see, we have 8 over X minus 5. And let's do last one, 7 over X Y. Hopefully you are able to solve this, but let's look at it. For here, for the first one, B can be anything except that B cannot be equal to 0. So it means that this equation is impossible if B is equal to 0, right? Here, when C is equal to 0, so C cannot be equal to 0, because then you have A over 3 times 0, and that will give you A over 0. And no matter the number that A will take on, because we are dividing by 0, that will not work. Here, either of these, S cannot be equal to 0, Y can also not be equal to 0, because either of them, if X is, let's say, 10 and Y is 0, everything is going to wind up at 0. If let's say x is 0 and then y is, let's say, 12, everything again is going to wind up at 0. So here x and y cannot be 0. You understand? Now let's look at this one. I intentionally left this one. Here you realize that what number would you add to this expression to make it 0? Remember that we are subtracting by 5. So the number you can add is 5, because then 5 minus 5 will give you 0. The number that will make this equation impossible or undefined is x is equal to 0. And so in algebraic terms, what you would do is that you would equate this one to 0. So x minus 5 is equal to 0. And then you have to solve for this. You send this one to the other side of the equation. It is minus 5 here. When it crosses the equal sign, it becomes positive 5. So x should be equal to 5. You understand? So this is also a very important thing to kindly take note of.